so let's start. So today we'll solve GATE 2017 question. This is a question from functional analysis. It is a question number 13. So what it is saying? Consider the non-linear space. Consider the non-linear space R2 equipped with the norm given by this norm. So this is a L1 norm. And the subspace is given by x equals to y. And let f be a linear functional on x given by f of xy equals to 3x. If g of xy equals to alpha x plus beta y for alpha beta in R is a Harmonic extension of f on R2, then alpha minus beta equals to, we have to find. Okay. So this is the NPTEL reference. This you can look into it. Okay, now let's solve this one. So what this is, subspace is given of a means vector space R2 of, and so it is saying that, so let me write. So R2 is equipped with this norm x, y, let me call it, let me write it this, where the norm is, it's mod x plus mod y. So this is sometimes also called L1 norm. And what else is given? X is a subspace is given. X is a subspace of R2, all xy in R2 such that x equals to y. So this is a diagonal subspace. So let me write. So suppose this is x, this direction is y, so then this line is x equals to y. So this is the subspace x. This is 0, 0. And f be a linear functional. Let f be a linear functional on x given by f of xy equals to 3x. So basically x here y equals to x. So this is the linear functional on x is given. And what else is saying? Let g of xy equals to alpha x plus beta be the Harmonic extension of, is a Harmonic extension of f of R2. So let g of xy equals to alpha x plus beta y for alpha beta in R is a Harmonic extension of f on R2. So if what is Harmonic extension? It is saying that Harmonic extension is basically saying that if a functional which is defined on a subspace, then you can extend it to a whole, that vector space, whole vector space, without extending the norm, means with norm preserving extension. So Harmonic is saying that means from Harmonic extension we got as, means G is a Harmonic extension of f, Harmonic extension of F. So we have two property. First one, what we have? G, if we restrict it to X, it will be same as F. And second one, so norm of G, so this is our whole vector space R2, let me denote it, and norm of F over X should be the same. So these two harmonic extension tells that you can extend the linear functional F to a whole linear functional on R2, which is G, given by G, with preserving the norm. Okay, so we have to calculate the G basically. So let's calculate G. So from the condition 1, what we will get? So from condition 1, from 1, what you will get? That G of xy restricted to F, you will get F of xy, or what you will get? Alpha x plus, so on x is beta x, right? And this side it's 3x, as xy in x imply x equals to y. So you get alpha plus beta x equals to 3x. So this is for all x in R. So therefore you will get alpha plus beta equals to 3. So you get one condition on alpha and beta. Now from 2 we have to deduce another condition, and from there we have to solve alpha and beta. Okay. So for that we need to compute the norm of F and norm of G. So let's calculate the norm of F and norm of G. So what is norm of F? So norm of F on X means, so it means this is a functional norm, means supremum of norm of xy, this should be less than 1 such that F of xy, where this xy is in is x, right? Now what is this? So xy is norm of xy, so this is, if you write it, so it is supremum over, this is mod x, and as xy, so it is again mod x, so this is less than 1, or you will get 2 mod x is less than 1, or mod x is less than half. So you will get this condition. So supremum over mod x less than half, and this is 3x. So means this is less than, so this is less than, what you will get? 3 times mod x, which is less than, so let me write, which is less than 3 by 2, because mod x is less than half. So you get norm of F is less than 3 by 2, but we need exactly. So let's find a point for which the norm will attain. So let's take which point? Let's take this point. Take half comma half. So as x equals to y, so this belongs to x. And what will be f of half comma half? So this is 3x. So if you put 3 into half, it's 3 by 2. So at 1 comma 1, the f will take the value 3 by 2. So the supremum is attained at the point 1 comma 1. So norm of f is 3 by 2. Therefore, norm of f on x is 3 by 2. So you get the norm of f. Now you have to calculate the norm of g, and then we have to equate these two. So what will be the norm of g? So note, now we have to calculate norm of G on R2. R2 with which inner product? That norm. So basically this is a linear functional, right? So what is the dual of this? So G is a linear functional on R2. So note that. So this is a well-known result. It is known that dual of, so this is a dual R2 with L infinity norm, suppose take, and it's take dual, means all linear functional on this space, which is isomorphic, and R2 with L1 means all linear functional on this space. So this is isomorphic to R2 with L infinity norm. So what this is saying, and this is isometrically isomorphic. And basically the map for any given psi here, if you map it to psi of first basis vector e1 and psi of e2, this map will give the isometric isomorphism, right? So this map gives the isometric isomorphism. So with using this one we can compute the norm of G. Means here what it is saying, that psi here the L1 norm, means in the dual norm, which is same as this maximum of psi e1 comma psi e2. So therefore similarly G is in the dual of this, right? So therefore as G belongs to R2 with this dual, so basically this norm is the L1 norm. So dual where this norm is the L1 norm. Which is the L1 norm. So norm of G will be, so by the above observation, norm of G will be maximum of GE1 comma GE2. And what is GE1? GE1 what is? So G is alpha, E1 is 1 plus beta dot 0 is alpha, and G of E2 is alpha dot 0 plus beta dot 1 is beta. So we get norm of G is maximum of mod alpha comma mod beta. So now we get, so this is a norm on, so now we get both the norm. Here we get the norm of G is this, and norm of F we earlier get this. And by the condition 2 it is saying that norm, both these norms will be same. So by 2 we get norm of G is same as norm of F, which implies maximum of mod alpha comma mod beta is 3 by 2. So let me call it true, and we get earlier one condition. From the condition 1, this is 1. So we get two conditions, 1 and 2. So we have to solve these two. Therefore we get alpha plus beta equals to 3 by 2. This is condition 1. And maximum of mod alpha mod beta is 3 by 2. Now we have to solve these two, alpha and beta. What will be the possible values of alpha and beta? So note, can alpha and beta both be negative? Note, alpha and beta both can't be negative. If both are negative, then the sum will be negative, so it will not satisfy the first one. Right? So both cannot be negative. So can one be negative? Suppose alpha is negative and beta is positive. Then what will happen? So note that if alpha is negative and beta is positive, then the sum is positive. Means one number should be, suppose it is non-zero also, assume. Right. So suppose one is, alpha is 0, then beta is 3 by 2 you will get. And so suppose, assume first both are non-zero, then what will happen? So if alpha is non-zero, then if it is negative, then the sum will increase, because then the one should, suppose let's say if alpha is negative something, then as alpha plus beta is 3 by 2, then the beta should be bigger than 3 by 2, which will contradict the maximum of these two will be mod of these two is 3 by 2. So also one cannot be negative also. So both should be positive. So either alpha or beta cannot be negative. Right. So both should be non-negative. Now what are the possible values? So suppose 1 is 0, alpha is 0, then what will happen? If alpha is 0, then what will happen? Then the G, what you will get, is basically beta y. Then if alpha is 0, then beta will be 3 by 2. So basically you will get there are possible values. That means if 1 is 0, then the extension will be, what will be the extension? Means there is no it's not a non-trivial extension. It is the same as f, right? Because 1 will be 0 and on x equals to y it is same. So it is not a non-trivial extension. So both, if 1 is 0, it is not a non-trivial extension. So both should be positive. So as it is a non-trivial Harmanek extension, so it is a both are positives. As G is non-trivial Harmanek extension, so alpha, beta both are positive. Now what will be the possible values? So as sum of both the because maximum of now 1 can be 0, right? Can 1 be 0? If both are same, no, I think what is the sum we have got? Oh, I forgot. This sum is 3. That's why I am getting confused. This sum is 3. This sum is 3. So what will be the possible values of alpha and beta? So therefore, alpha equals to beta equals to 3 by 2. Yeah, also alpha beta can't be 0, right? From here, if alpha is 0, then beta, so alpha beta can't be 0 also. Also from this alpha or beta cannot be 0. So the only possibility is alpha equals to beta equals to 3 by 2. Then what do we need to find? We need to find alpha minus beta. Then alpha minus beta will be 3 by 2 minus 3 by 2, it's 0. So what will be the answer? The answer will be 0. Okay.